Hello, everybody. It's Larry. Um, it's Saturday morning. I'm trying the biweekly contest in 20 seconds, as you can see here. So, wish me luck. Ooh, man, cutting it close. I messed up my um, I messed up my video bar. So I think I'm the live commentary. The other one is I'm the commentary. The other one is the live one. But you'll notice it. Cool. So yeah, I didn't get that much sleep this one, but let's go. I thought, okay, away transformation. Hmm. So this is the first problem. I think the first thing I looked at was, well, I read the question a little bit. It, uh, but yeah, I read the question, and the first thing I always look at is the constraints. For here, I see that n is 100, and also the way element max is 100. That means at most there should be 100 iteration. So immediately I was like, okay, this is just brute force, right? Or simulation, right? I think I pretty much go to it directly on that. Yeah, and I started typing it out, and I was just debating ways of doing it, but ultimately, yeah, I mean, you could see it. It's pretty straightforward, I think. I have because n is so small, I didn't have to worry about performances, not just for because this is essentially n square, but even n square memory due to reallocating memory stuff. I probably didn't need to do it. Now that I think about it, I mean, I didn't think about this during the contest, but now that I think about it, I probably could have just fixed the way instead for the so then I don't know, it saves some um, memory allocation as you kind of see. Um, but I did it very naively, and it still passed. So that's sometimes that's all you can ask for is thing to pass. So here I was like, wait, what am I doing? I don't need this. I could actually just do this directly. I was going to copy it and then do some in-place modification. And then I was like, no, just do it in-house and quit. Start the way every time. And then here's the condition that I mean, this is oh wait, well, this is that if it's on a boundary, just put it in. Else, and this is just essentially what you read on the problem description, which is if this element is bigger than its neighbors, plus one and so forth. I feel like I think there's something to be said about sharpness, and I wasn't that sharp this round. And what that means is that when you're feeling good, when you're feeling well, the first time you type something, you just get it right, and like in a clean way. And I definitely felt like I was a little slow today, but that's okay. Like I'm not trying to be the top person yet. Just something respectable. Here I did have a little uncertainty around how array destinations work, um, or assigning arrays work, whether like it does a copy or like I changed the memory reference, but thankfully it was okay. Well, I did one the bug, and I was like, wait, what? This doesn't make sense. And I thought there'll be two possibilities. One is that what my assumption that it will terminate is not true, or I have a bug somewhere. And it seemed like it should almost always terminate. And I was like, so I must have a bug. And you see it here where I just choose the same neighbor twice, and then once I because yeah, I submitted immediately. I didn't think there would be any edge cases other than that. So and then it submitted. Problem 2, design a leaderboard. Okay, here I'm just reading the problem. Unfortunately, incorrectly, as you will kind of see very quickly. I think I'm just still reading. I'm like, maybe I'll use Python. I think even at this time, I was actually thinking of something heapy by using a heap. Um, but I actually, at this point, I was like, huh, would this really run within running time? Maybe there's something I didn't notice. Um, and unfortunately, in a weird way, I noticed that maybe roughly here, I noticed that score is 100. So I was like, oh, it's update score. If score is only 100, like right there, I think. If score is only 100, then and we could just keep a hash table and then just count down uh, uh, yeah count down the scores, uh, uh, count down from 100 and then sum it up that way, and you'll see me spend probably the next, I don't remember how long, but like I guess we'll see, for like 5 to 10 minutes coding that implementation. I was just in my mind right now, I'm just debating whether that'll be like different variations would be fast enough. um, I think right now I'm trying to figure out if 100 is fast enough for me to do it that way. But it's only 1,000 function calls, so I was like, it's only 100,000. Should be okay. Briefly debated implementing in C++, but then I was like, hash tables, at least for me, more. I mean, you gotta go with what you are good or familiar with, and that's essentially what I'm doing here. Um, Even though I'm making a mistake, so yeah, and I did the thing that I was talking about earlier, where yeah, I was keeping a hash of some sorts, but I think right now I'm just thinking whether I should change that into like an array of 100 elements, uh, because at the time I thought that the max score could only be 100, right? Um, uh, Poor Larry. It's kind of actually a little hard to watch yourself like stepping through your mistakes in real time, but but I was just like, it's okay. 100 hash cores should be fast enough in either case. So I'm just writing the reset right now. Yeah, I was trying to implement this. This is right now like 4 or 5 minutes in. There's kind of like a reverse counting thing of the rolling sum. This is pretty standard. If my assumption had been right, that, I would have submitted very. I mean, I did submit very quickly, but um, hmm. And unfortunately, for me, well, there are two errors here actually. There's an error coming up right now where yeah, I put the K before the addition, so even if I had gotten the right algorithm, this is what a silly mistake, which is why I'm talking about robustness. Got the wrong error. Which one was this one actually? Oh yeah, I mean, I just didn't set the thing. So I just had to set a default thing because I use plus equal to it instead of just a assignment, and that's what happens in Python. I'm like, oh, this isn't that right, and I realized that I printed out first, which is wow. Now that looking back, I actually made a lot of mistakes here. But I was like, oh, yeah, you have to obviously put the return statement outside the while loop. Otherwise, it just goes very quickly and returns 0 for your first element. And then I was like, what is going on? What am I missing? Am I misreading the problem statement? The answer is still yes, but I still also got that wrong. So let me print that first. I was like, oh. I think after getting the print statement, I was like that doesn't make sense. Well, I mean, okay. Here, there's just too much statements. So I moved the print statement inside the if statement, I think. Okay, not yet, but I will do that next. Yeah, I meant to do that manually, mentally. That didn't even make no sense. Okay, there you go. Yeah, and I was like, huh, it doesn't add. And then I looked at my formulas. I was like, what am I doing well? And I looked at my formulas. I was like, oh yeah, case 0. I don't know if I would normally find it faster, but oh, okay, well, now that I remember this part, I was like, oh, k is 0. Why is k 0? Bam. So in theory, this is right, but only because uh, I tried to submit. I mean, I ran one more time, but then I submit. Well, now I submit. But I was like, huh, why is this wrong? Maybe that was a risk, but. And I'll make a comment here, I think. Maybe I don't. I'm going to make a comment here. This is impossible to read, but yeah, I think my comment here was just that it was very hard to read and debug the input. And I had to like go one by one to see what the error is. And I was like top one. I mean, eventually it's a little bit slower. I said top one. How did that happen? Or like, and then I looked at the result. I was like, oh, top one is 160. Why is top one 160? And then I figured out that I was solving the wrong problem. I mean, kind of. And then I just end up using the heap anyway, as you see.
Just top
in
one.
a minute. So now I'm about 16 minutes in. So it seems like after I used the heap, I solved this in 3 minutes. I mean, I didn't know this at the time because I wasn't looking at the clock or anything. But I think I just did more constraints math on heap.
No, is add score literally add score? Oh.
Yeah, he was not happy that he was not happy that it was add score instead of whatever. I'm now trying.
For some reason, it's change score. Okay.
Now I'm trying to figure out what to do.
That's a little trickier. It's fine now.
Like I need to throw everything away, and sometimes the answer is yes. There's no way around it. I was thinking of doing like a in place heap so that you update on add score. But I was like, how is that feasible? I'll try and like look at the constraint to see for guidance. I think most of it. I mean, the typing is very quick. I think I was just like deciding if that the heap makes sense where it's live, and I was like, nah, maybe that doesn't make sense, and I'm like trying to figure out how to change the code now. And I was just like, okay, this should be good enough. And then now I have to change the default so that this is easier. I mean, essentially, this becomes like, yeah, like 10 lines of code. So it's actually very quick. I think on the scoreboard, it cost me one submission, one incorrect answer as well. I think I end up spending like 12 minutes on this or something like that. But and this is just standard. I forgot how to do the YU syntax for Python, so I was just like, whatever, just do it this way. It's close enough. So you could actually put that in one statement, but you need to remove that. And I always forget whether the Python heap is min heap or max heap. So I actually just printed out just for quick debugging. In the meanwhile, this fails because of the stuff in reset, but and it complains, but by the time I look at it, I'm like, okay, can we just run it again then? Because I already fixed whatever it was complaining about. And I was like, oh, okay. Now that I confirm there's a min heap, I pop off if it's more than k elements, and then just sum the elements. I was like, okay, this is right, and maybe I just submit. And I was like, yay! So that actually ended up taking 6-7 minutes on the redo. I was both happy and also like, maybe like, because that's like the dumb algorithm, the obvious algorithm that I thought I needed to be a little bit cleverer, but don't prematurely optimize. Yeah, so problem 3. So this is the tree diameter. I think tree diameter is a very well studied problem, and I wouldn't say it's something that you encounter that often. Only in the sense that it's because it is like a known problem with a known solution, and it's something that if you practice a lot, you'll come across it, and then you'll just remember it. Um, but that said, it's kind of hard to prove it to you. I mean, it's not that hard to prove it to yourself, but it takes time to prove it to yourself that the algorithm is right. And for me, I've been trying to be a little deliberate on this contest because before that I've been just going on gut and but with a lot of incorrect submissions. I just want to see what.
Wow, people are already.
Yeah, I just want to see what everyone's doing, and
not surprised.
just to make sure that like I was in a good place. I was okay, but a lot of people finish fast, things very fast. But yeah, this is a known problem with a known solution, and once you've done it once, you'll probably remember it. Or if you don't remember, I mean, like you know that solution. But for me, I've seen this problem before, as I mentioned, but I was not confident about it. It's been a long time, and I didn't know if my memory held up to what my gut was right. So I tried to do a few things to kind of prove to myself. I was like drawing a little bit, and that's why I like started with writing stuff as farthest. But yeah. And then now I looked at the inputs. After I looked at the inputs, I was like, well, this is actually a list of edges, not in a place where we could use it very easily. So I convert that to an adjacency list. This is relatively standard stuff, even though the way I do it may be a little bit verbose. Maybe I'll figure it out. And then now I'm just thinking how to actually implement it. And also, I think at this point, I had some doubts about, just some doubts in general. As I was just really trying to prove to myself that this is right before coding, because the code the code was going to be straightforward. So if what I thought is correct, and I thought about using like a helper method, but I was like, maybe that's okay. And I changed my mind in a little bit, as you see. I think one thing I was trying to figure out is also like how to kick this algorithm off, and I just used there's no actually like the defined root, so I just took a random node and it's fine. Because the algorithm solution here is that you take any node, you go to the farthest node that you could find on a tree, and then you take the farthest node that node could find on the other side of the node. So then, so that gives you the answer. I mean, that for proof, there are videos on these proofs, so definitely just look through them, like on YouTube or something like that. But that's the algorithm, and I wasn't super confident about it, to be honest. Well, I mean, I mean, it's correct. It's just that I wasn't super confident about it because I haven't seen this problem or haven't done this problem in a while. I was trying to do some clever things with height to the left and height to the right, and I was like, maybe I could prove this easier with the smaller ends. But then I always mess up 10 to the fourth and think it's 1,000, but it's actually 10,000. So I was like, oh, if I'm going to do it this way, it's going to be like n square, like this other way, which it's more obvious that it's correct. But then I was like, n square for 10,000 is actually not fast enough. So yeah. Oh yeah, and I also check an edge case. Get it? Edge case, edges. Okay. Because I take the first node or the first object from the edge list first. Oops, I don't know what I clicked on, but um, yeah, because I take the first node, so if that doesn't exist, then like it would fail. So I was like, okay, I have to check for this. I think I take a quick look at the constraints, but I was like, okay, yeah, return 0. That's the case. I mean, right now I'm just still try to prove to myself that the O of N algorithm works, even though, I mean, it's fine, I guess. I end up taking, I think, 13 or 14 minutes on this problem, which probably could cut down about 5 minutes. Well, 13 minutes, I probably could cut out like 5 to 8 minutes if I go directly. I think that's about my speed. And also, I think here I remember that I don't need to do these crazy OOP ways. I could do an inline helper function in Python. Would not recommend it on necessarily anything, but yeah, and I was just trying to figure out like, did I get this to return or whatever? But I was like, whatever, just like keep track of things, which you see I do in a bit. And this depth first search is very standard depth first search. I mean, it's like 3 lines of code, 4 lines of code. Excuse me. And basically, I implement the algorithm I mentioned at this point. I was like, gotta go for it. Yeah, and like I said, I just do it twice. I think here, I do spend some time worrying about off by ones. because we want the number. I remember that we want the number of edges and not the number of nodes. This is actually wrong. I was just, and I wasn't super confident about it, or I knew that there's something quite weird about it. So even though it was correct answer for maybe even for both, I was like, no, that's not right. I knew I forgot or I haven't done anything or something yet, and like I didn't feel right enough. I wanted to be super sure, so I want to print out the scene away first so that I could see what the state of the row is. And once I see the state, I was like, oh, this is clearly wrong, like why is that the min rate? And then that's when I realized that I've actually skipped some stuff. I have a typo here, which I fix. I wish things are scoped correctly and an edge is not a thing, because that took me a little bit longer to figure out what it meant. But I had a typo, and I happened to use the same variable as before. I was like, okay, this is kind of good. Well, it's better, but it's definitely wrong and different because I didn't, I had to basically just fix the thing. I could fix it in a number of ways. I thought this was a little bit cleaner, or just easier to fix. And then now I was confident about it after looking at the scene array or scene matrix output. And I was like, wow, this judging is taking really long. And then, yeah, cool. So at this point, I think I'm like half an hour in. I think I was just trying to read the poem right now. I mean, it's a classic n-square dynamic programming poem, or n-square states, n-cube running time dynamic programming poem, and that's how I treat it immediately, though, I end up taking a long time to solve this for reasons that we'll go over. Yeah, I was just like, what language should I do it? Let's do it in C, why not? Did I end up doing this in 3 language? I don't remember. Yeah, I did the first one in C++, so I guess I did. Maybe one day I'll do it in 4 languages. I didn't actually plan this out like this, so but still amusing. Yeah, so I immediately knew it was this. So I did write out the kind of what I call the skeleton code for it. But even though I didn't know how to kind of proceed per se. For me, it's just a base case. Because if you return all if you remove all the characters, that's what would be the answer. And then now here's the hard part. Try to figure out how to reconcile everything together, or like, yeah, I spent a lot of time on this. I mean, I did spend a lot of time on this. Here, I was just like, oh man, what is my rank? I updated. I'm like, well,
You go fast today.
202nd, not terrible, but definitely not great.
Faster.
Especially, at least for me, because I'm usually like faster on the slower one. So if I'm already 200th, that's a little sad. But I was like, yeah, whatever, let's just do it. I think at some point I also just see if CPU was running time, so I could have a gauge of how difficult this farm is. But yeah, I try a lot of different things, and yeah, and you'll see me try them. I'm going to jump ahead. So I mean, and I'll leave a link below on the description so that you could just click to kind of skip a lot of me trial and erroring. So yeah.
Does that matter? How would you do that? Guess you take two numbers that are the same. I guess that's what you split on.
default case. time left. Oops. Back. At this point, I was just let me just try to do something really brute forcey and dumb. I mean, not dumb, but I was just like, I know this to be correct, or like I was trying to get a little bit of understanding about it. Um, so I was just retyping a lot of things and just trying to see what was going on. I was typing at this time, roughly around this time, people in my building is like moving furniture or something. So here's something in the background, which I apologize. But basically, instead of having n cube, I think I convert this into like something like n fourth, which yeah, I was hoping that it was fast enough because I just couldn't figure it out at this point. Yeah, and the idea here that I was thinking about is just like, okay, instead of trying to figure out a way to given an array separate into two chunks left and right, maybe I just take like, hey, you know, something in the middle and then separate into three chunks, which is left, right, and the middle of the chunk that you're doing, which is the start and end. And I ensure that the middle chunk will only happen if the left and right are together, or if they're the same. So then it begins a palindrome, right? That's kind of what I do here for a little bit. Um, I think this, I mean, and it was correct, I think, and you'll see in a second, because I think I got through. I mean, I think for me this was easier to understand, so I got through this relatively quickly. Oh yeah, I had that typo for a while, so they wasn't doing anything. Um, Just more boundary condition. I mean, the first try I had to move some stuff up before the cache because it could be out of index. I was like, okay, got something. At least it passes the base cases. And then that's when I think I submit. Either now or maybe I added like one more test case. Oh no, this is wrong. So wait. I don't remember. I think I had added one more edge case on. I'm just storing the thing externally so I could have something to run, but yeah, I didn't need that base case anymore because of how I handled extra costs. So then that fixes it. Passes the tests. I submit.
That was why I
time to mix either, which is actually, yeah. I mean, it was kind of expected, but I also thought like I was like, I was wrong the other time too, right? So like on the other problem where, you know, I didn't do the more naive thing, so I was like, oh, I mean, it only took like 49 milliseconds or whatever.
Tips doing the thing, but
so like I was like, okay, I have it in memory or in my pace bin, copy bin. Yeah, it only took like 44 milliseconds, but it's still not fast enough. So I was like, I guess if I do really need that n cube one. And right now it's about like an hour and 15 minutes in, so I have about 15 minutes. I was like, well, no way about it. And I talk about this a little bit later in the retro, which is that yeah, I just thought that I think this, even though this was incorrect and gave me a bad submit, it allowed me to like really break down the cases into what I was doing wrong earlier in this problem. And I don't know if you look what's going through it, but I was trying to like when I break something into two pieces, I was trying to. There's actually more cases than that, at least the way I was doing it, because apparently there's another solution that's actually way easier or straightforward, but I don't know if I understand it to explain it. But when I separate into two pieces, there are actually two test cases that I was trying to, or two distinct scenarios, and I was trying to merge them into one. And here I eventually just I wouldn't say I gave up, but in the sense that like I was like, okay, let's just actually enumerate them and break them into two cases that they are, and that's when I thought about it. I think I mean that's a little bit later, so this is maybe a little bit of a spoiler. I think when I'm just thinking about what to do, and I looked at
13 minutes. That's not great.
Yeah, I have like 13 minutes left, so I was taking a look.
I know that's
just how much time I have.
How I would do it, but
couldn't figure out the recurrence. Yeah, and I just couldn't figure out the recurrence, even though I knew the other way was how to do it roughly. And at this point, I have like about 13 minutes left, and just try to figure out like how to think about it. This is Larry, deep in thought. I don't have anything in the ceiling, I don't think. I don't know what I was looking at.
yeah, it's worth a try.
Just deep in thought, I guess. I was like, just give it a try. 13 minutes. It's dynamic programming. You know, like the correct solution is not that far off in terms of typing. I'm trying to do the left first. I don't know how I came about this epiphany, but I did kind of was like, okay, actually there are two cases, so let me just type them out. Well, I was actually starting with one case. I was like, okay, let's just start with the basics. What happens when mid is equal to left, the elements? Or when, like, well, this, because in this case, you always take out, what I was thinking is, you always remove the first character, right? Can you remove a middle character with it? And that kicks off like a part of the palindrome, right? Um, well, actually, no, I didn't think of that. No, that's not the way to think about it. Now that I think about it a little bit more, um, the way I thought about it was that, okay, I'm removing this middle element last. Can I match it with the left or the right? Um, and let's say, and how can, and what are the costs of that? Um, and whether that starts a new palindrome, which is what the third element is for. Um, and that's the case, like what's the cost? And yeah, so I'm removing this middle element last. What are the can I remove it with the left or the right to kind of continue that palindrome as it kind of goes from a bigger subproblem to a smaller subproblem. Yeah, and here I was just like double checking in my mind the test cases. Didn't have time to think about it more, but I think the way I did it, there are definitely a lot of overlaps on the subproblems, so it actually is not that bad because the else part is actually like mostly just array lookups. I could probably have at this point, like now knowing what I know, I could merge them together, but I was just having too many issues with that. Um, it's fast to have one bug. One is not great. I was like, yeah, well, that's not anywhere close to being right, right? I mean, that was an unfortunate correct answer, which I was like, that doesn't make sense. And then here I was like, wait, that makes even less sense. Or it gave me the right answer, but I knew that I don't have a right solution, right? So I just kind of do the old school debugging of printing stuff. And keep in mind that at this time, I have about 8 minutes left. So I was, you could say I was, but I actually didn't feel that pressure. I was just like, well, I did an okay contest at this point, and if anything I do, it's for free. I was like, that doesn't make sense. None of these make sense. I was like, oh wait, at some point I went like, oh wait, I didn't keep track of the costs when I split. So yes, I do something like that. Um, and it was too high. Because I was like, oh wait, uh, you know, it could be in the this current digit could also be in the middle of a palindrome, and this is the end of a palindrome. So that's why I changed that here and changed that here, and then And I was like, huh, cautiously optimistic, obviously. Let me try my big case first.
Whew.
Like, okay, well, I
Wow.
got the right answer, and it's
Oh,
faster.
okay. I
And
mean,
then I first made
look, I didn't get a fast time, but
there you
I'm
go.
still proud of myself. Hmm.
Should have gotten
Okay.
that way
Well,
faster though. But I was trying too hard to merge both these cases at the same time. I think I should have clearly done this.
okay. The other
to
lab we
begin
will
with,
talk.
but so, and that's the part that I had trouble with. Okay. Well, oh man. I mean, anytime you solve all four, you're still happy. I'm going to drop a little bit though because of the two penalties. Uh, that should have been maybe more. I mean, okay. Let's go over each problem by problem now that I solved it. Okay. Yeah, I mean, could have been better, could have been worse. Okay, cool. So wave transformation. I mean, this is just simulation, right? I don't think I have much to explain. You see that you're only going to make 100 iterations because each element of weight is less than 100. So like at some point it will stop. Um, so yeah, so just simulate for the first one. Second one, design a leaderboard. Yeah, I just totally misread this. I read add score as update score to change score. Like otherwise, I mean, I guess even in that case, this would have worked. I guess my issue here was that I didn't look at the constraints enough. I thought that using a heap every time instead of keeping like a running state would be too slow. And because I thought it said update score, I just thought that we could just do 100 iterations each and that'll be okay. But turns out that because the scores can get higher than higher than what do you call it? Higher than 100, that my algorithm was wrong. And unfortunately, this test case doesn't change how I thought about it, which was unfortunate. But yeah. Hmm. Yeah, I mean that's what I had to say. I mean, otherwise it's just keep it, or every time you get the top scores, you just run it through a heap, uh, and this is log k instead of log n, which is slightly faster. But yeah, tree diameter. Thought I did this one faster. I mean, I should have done this one faster, but to be honest, it's some like I knew how to solve this right from the get go, but it has been like some of this is that this is a very specific algorithm. So even though I knew how to solve this from the get go, I had to prove to myself a little bit, and that took a little bit of time because I wasn't confident about it. Even though I knew that's how you find a diameter of a tree, and it's very specific in the sense that like I've seen it before, right? Like it wasn't because like but I, but it has been a while since I've seen it, so I wasn't confident about it. Um, but the idea here is you just do two depth of search. You do a depth of search first, and then you take the farthest point, and then from that farthest point, the second farthest point, or the farthest point from that first farthest point is your diameter. And I just do like a -1 because you want the edge instead of the nodes. Um, yeah, that one's pretty straightforward. I mean, if you've been watching, you saw me struggle a little bit. Um, I mean, my major thing was that I was trying to combine these two cases into one case, and I just struggled a lot because that didn't make sense. And I think looking back into like I think I had that intuition where I was like something is just really off, and I couldn't figure out why. Um, but uh, but after I separate them out to two cases and barely get it in under the gun, um, I solved it, so it was okay. But basically, the idea is that yeah, you just calculate, like, so for each left and right, each boundary, like, what does it mean to, like, what's your so there are only two combinations or two possibility when you're within like a boundary, which means that this is inside a palindrome or it is not. If it is inside, then you take off some edges and there's some stuff about cross counting, but that's mostly it. Um, like I'll go for one case. For example, if you have like say even like 1 3 4 1, which is the one I was playing with. Um, Now, first of all, well, we get the edges, the 1 and the 1, so we could kick that off. Okay, maybe this is a bad example actually, but maybe 5. Right? Let's say we start with this, which is an example. Well, what if we start the palindrome from 0 to 4, right? Because they match. Well, then we just break down into two subproblems, and the subproblem on the right is trivially 1. I think that's just one of the best use cases. And the one on the left, well, we kick it off because if they're the same, then we kick it off by stripping the outer borders, and then this is inside a palindrome, right? So that's kind of how I did it recursively, and each of the statements kind of reflect that. And I was really trying too hard to kind of combine these two things into one place, but obviously I didn't need to because once I separated them out, I got it relatively quickly, which is very nice because I didn't have much time. I have 45 seconds left after talking about it, so I didn't really needed to get it done. But I imagine, yeah, but seeing the scores of the higher performers, you gave me a little bit of hint as well that it was not something intractable. I mean, I've always, if you watch my stream, I've always struggled with the left-right type of n to the cube dynamic programming problem, and as a result, this actually, just boosts a little confidence in general. So it's always nice, even if it took an hour and 20 minutes or whatever. And my code is relatively understandable, maybe not. Let's see after all. Yeah, so is that my final score? I guess so. Okay. Yeah, so my final rank is 107. Not too bad, considering that I took so long on this. I guess now that time's over, I might as well take a look at the other ones. Yeah, I mean, for one submission error, he still finished first. Very impressive. Been a fan of Urchin Toe for a long time, but yeah, my other excuse, if you're curious, is that I had to wake up for this. Had a long night, so so I only had like 3 hours of sleep, but that's still an excuse. I mean, yeah, I mean, use it. Oh no, I'm looking at my exit. I was like, that code looks familiar. How does he talked about sorting, but what's temp? Maybe I don't understand this route. I don't know what nth element does, so maybe I just don't understand that one. But and apparently, you could even do something dumb. You don't even need a heap. You just sort every time, and that's good enough. So I really spend way too much time. I'm usually pretty fast on these quote unquote obvious ones, but I just thought I really thought that if you sort every time, it would be too slow. But clearly, I was wrong. So that's why a lot of people got past. I mean, I imagine, to be honest, I don't know. Yeah, I mean, I should have done faster. I mean, I tried to prematurely optimize and also misread the problem, so maybe that's why. Okay. Wow, I did it. I mean, yeah, I mean, I'm not surprised. I think, to be honest, even though it took me a while because I had to reprove to myself, this is I wouldn't say it's standard, but it's a pretty known problem with a known solution. So, so in that case, that's probably how everyone got it like within a minute or two. If I was more confident about it, well, this is not the same though. But yeah, if I was more confident about it, I definitely could have done faster. But I'm happy with that. And yeah, and I mean, they even show up to bottom up. I don't know how to bottom up still. Spread on n cube ones. Um, this is actually even better. This is an n square one. That I have to read this a little bit in the future because obviously it's just n squared where mine is n squared times 2 space and states. But clearly, a lot of people know how to do this once. People are very smart. uh, but well, I guess they do it on length instead. But I mean, and don't I try to do something like this? But yeah, I guess that's another way of thinking about it. Okay, wow. I mean, this is definitely cleaner. Yeah, okay, wow. I mean, that makes way more sense, I think. Um, I would, I think for me, especially not this one, well, I mean, I used to recursive one first, but I think for me, that was a weird recursive. Well, like there's some offset there, so I don't want to use that as a highlight. Where's the one that I looked at? Man, a lot of people are like really good in doing bottoms up. Well, I mean, I think, yeah, they also looked at they have a different recurrence than I did, to be honest. I looked at it actually a little bit different, but yeah, the way they did it is more clever because actually I'm not sure. I mean, I get it. Okay, I don't know, but yeah, I mean, hmm. Because implicit in this split is the cost of an extra. Okay, I mean, I think that's smart. I clearly did not think of it that way. I was. I mean, that's not true. I mean, I think um, I was halfway like between that one and like I tried to build that as one of the edge cases, but I just didn't get there. Like I think I was halfway between what I had and what I was doing. So yeah, I mean, the magic of dynamic programming is that it seems like there's always more for me to learn. All right, I think that's all I have for today. Yeah, I mean, overall, I mean, I finished off. I mean, I finished in 107, which I guess could have been higher, but you know, oh man, I lied. Did I not refresh before? I guess they just was cache. Anyway, finished 134 out of 2900, which is okay. Um, yeah, I mean, could have been worse, but I feel like I am definitely not up to stuff. Some of it maybe is that I needed more sleep. Some of them just more confident. I mean, people clearly gotten this. Oh, how does this work? Is there just like some like does China run into one in a different server or something? Because we clearly saw Urchito first. I don't know, but yeah, yeah. I mean, overall, I felt okay, but maybe my takeaway is maybe get more sleep. Definitely, I mean, I'm okay with my performance. Like for example, for problem three, like I knew the problem and the solution, but I just didn't wasn't confident. So I had to prove to myself a little bit, and that took probably like 10 minutes to be honest. I try also this for this contest to be a little deliberate, in the sense that I'd rather be a little slower and correct and not have a incorrect submission that took that cost 5 minutes. I think in the because I that's somewhat compensating for me in the past. Uh, just running up a lot of incorrect submissions, right? Like this one was kind of bad. Well, but that was just misreading the problem and the solution didn't or the test cases didn't catch. This one, I mean, this the first time the incorrect submit it was a Hail Marys, as in like I had nothing to lose, let's just try it. Um, and yeah, and then yeah, and nothing to lose, so I just tried it, and then I was like, oh wait, maybe this makes more sense if I split them up. I don't know. I just had a very lucky input for me. I don't know how I could and I got it literally near in the end. Uh, so yeah, overall 134, not so bad. All right, see you later.